In this problem, we are asked to differentiate y equals 2x plus 1 to the 5th power times x cubed minus x plus 1 to the 4th power. And of course, by differentiate, that means we need to take the derivative of this function. On the first glance, it looks fairly difficult. We've got things to the 5th power times things to the 4th power. But actually, while there are some layers to this problem, it's fairly simple. And it's fairly simple because we are just dealing with taking derivatives of polynomials. And taking derivative of polynomials is always a lot simpler than anything else. Now what we have to notice first is that I have a function right here being multiplied by a function right here. So I have the product of two functions. And when I find the product of two functions, and I'm trying to find the derivative of that, that requires the use of the product rule. So that is saying if I have these two functions, I need to take the derivative of f of x times g of x. That is equal to the first function times the derivative of the second function plus the derivative of the first function times the second function. And that can be flip-flop. You could find the derivative of the first function times the second function plus the first function times derivative of the second. That is, rearrange that order. And that would be because addition is commutative. Okay, so that leaves us, we need to, as we set forth to find y prime, derivative of y, we need to first write our first function, and you just write it just as it is. So I have 2x plus 1 to the 5th power times the derivative of the second function. And I am going to keep things fairly, I got the first function right in there. Keep things very longhand because there are layers to this. And it's always nice to have good notation when you have multiple layers. What do I mean by the layers we have? In order to find this derivative, I have a function inside a function, the function of x cubed minus x plus 1, all inside the function of u to the 4th, some power function. And that is going to require the chain rule. So that's why I'm writing this out longhand just with derivative notation. All right, and the next one, it is plus the derivative of the first function to the 5th power times the second function just as it is. Okay, now we gotta go through simplifying this. 2x plus 1 to the 5th times, okay, so what is the derivative of x cubed minus x plus 1 to the 4th? As we already said, it's a function inside a function. So the derivative, the chain rule says, and I can write that over here, d dx of f of g of x. So when you have a function inside a function, that is equal to derivative of the outside function evaluated at the inner function times the derivative of the inner function. And a lot of times this notation is a little easier. What is ddu of f of u, where u is a function? Well, that's just derivative of the outside times the derivative of the inside. So our outside function back over here, our outside function is u to the 4th. So we have f of u is equal to u to the 4th, which means f prime of u, using the power rule, is 4u cubed. And then derivative of the inside function being x cubed minus x plus 1, is equal to 3x squared minus 1. So we put that together in our chain rule. We have f prime of u, so that would be times 4. Well, let me keep it the green so you see where it's coming from. 4 times u cubed, and what is u? That's just our inner function. times derivative of the inside function, 3x squared minus 1. And that is the derivative of that second function there. So now continuing on in our product rule, plus the derivative of 2x plus 1 to the fifth, derivative of that guy. Okay, so on this one, let's go with red. Here my f of u is equal to u to the fifth. F prime of u would then be 5u to the fourth. And what is my inside function? U is equal to 2x plus 1. So u prime is just 2. Pretty simple there. Derivative of 2x plus 1 is 2. Alright, so I now move that over and we'll put it into our product rule. So the derivative of 2x plus 1 to the fifth is derivative of the outside, 5 times u to the fourth, where u is 2x plus 1 to the fourth, times derivative of the inside, which is 2. And then that would be times x cubed minus x plus 1 to the fourth. That's our derivative, but of course we can clean that up a bit. We don't want to just leave it messy like that. So I will take this guy and let's move on down here. Okay, so this is going to equal, as far as simplifying here, I only have a 4, and I'll just bring that out front. So 4 times 2x plus 1 to the fifth times x cubed minus x plus 1 times 3x squared minus 1. So actually not much to simplify there. But in this one I have 5 and a 2, so I can multiply that and 10 times 2x plus 1 to the fourth times x cubed minus x plus 1 also to the fourth. And now I could, if I wanted to get real fancy, I have 2x plus 1 to the fifth here and 2x plus 1 to the fourth there. I could factor that out of all of it. Factor out 2x plus 1 to the fourth. Could also factor 2 out of these. But we will leave this answer as we have it here. And this, folks, is our final derivative. Expanded long looks really complicated, but dealing with only polynomials, it wasn't too bad to find the actual derivatives. So we differentiated our problem up here and gave us our longhand derivative down there. That is an example of a chain rule within the product rule. And the thing I can really give the best advice, write it this longhand way first. As I did in my first row, my first line here, I wrote ddx, I wrote ddx, I wrote where I have to take the derivative without actually taking a derivative anywhere. That helps keep our steps clear and focus on each derivative in and of itself, each part of the function in and of itself. Helps keep our work clear.